Hi, and
Hello.
welcome. Hello, welcome to this new Smode Academy session. And today we are going to discuss modifiers and masks, so chain of modifiers and masks. And the final purpose will be like to let you feel the common structure of all layers in Smode, be it texture layers, geometry layers, or shape layers. All of those, they share a common structure which induces a common spirit of content creation in Smode. And this is what we are going to try to let you feel today. Erwan is with me today. Erwan?
Yes, hi everyone. So if you have any question about modifiers, mask, or everything about Smode, don't hesitate to ask on the YouTube chat, and I will forward your question to Francis and try to answer it also. So Francis, please.
So let's start without waiting. So we are going to create a new compo and do a very quick recap of what we have seen in the intro on 2D compositing in Smode. So first we create a layer. So I will take a ISF generator. So ISF is a format of shaders that was developed by Vidvox. And Vidvox provide a very nice library, and also it's open, so anybody can contribute shaders for this. And then they can be imported inside Smode. So it's a very nice collection of shaders. And to illustrate this, I'm going to take the tapestry fract. So it's a fractal shader. By the way, you can see the shader source code, which is here, and which can be directly modified. That will be the topic of another live. But I'm going to play the transport of the fractal to let it move. So for this, I create a standalone player. So I won't go over all the options again. We saw this yesterday, but we could change the speed, back and forth, and so on. But our topic today is on modifiers. So let's create one. For example, blur. So I remind you that you can directly access to presets via this menu, or instantiate the effect in its default state like this. So by default, it's a Gaussian blur. We can make it a bit bigger, zoom a bit in the image. We don't need the left column for the moment, so we can close it like this. Oh yeah, so Basil lets me know that it's better to see me here, so let's keep the column like this. And instead of Gaussian, we are going to take the ring shape, which creates this nice ring effects on the fractal. So maybe we will do a live session on the blur effect, because it's actually a very complete blur solution where you have many different possible shapes, and you can go even beyond those shapes by entering in the custom mode and like construct your own blur algorithm. So it's very powerful, but I won't enter in the details now. Simply what I can do is change the way the input image is blended with the blurred image. So instead of replace, I'm going to put this in additive. And now we have this nice looking ring style glow effect. So for the moment, what we have is a layer made of a generator, which is the ISF, one modifier, which is the blur, and it's displayed once. So as a reminder, you can add multiple renderers to any 2D layer. So now I have one first renderer on one side and a second renderer on the other side. So let's say these are like two different displays. So I'm currently working in a compo because it's simpler for the demo purpose. But all of this is also relevant inside projects when you have multiple LED screens or video projected surfaces, for example. So now we have one generator, one modifier, and two renderers. And you can also create modifiers inside the renderers. So to illustrate this, I'm going to take a color LUT table. So These are like color profiles, like you can think at it like Instagram filters, for example, and it will recolorize all the image given a given color profile. So now I take one for one renderer and another one for the other renderer. So if you want to browse the color profiles, you can use the File tab and then go through the different profiles that are provided or create your own. It's a standard format. So let's take the golden version for this one and another variant for this one. So these are local modifiers that only apply to one specific renderer. And also as a reminder, every modifier in Smode can be modulated with masks. So for example, let's say the ring blur, I don't want to have it on the whole image, but only in the center. I can create a placement mask, for example, and use the feeder parameter. And now I only have the blur, so this is without the mask, it's blurring everywhere. And with the mask, it's blurring less on the sides. So by the way, you can use this green arrow to visualize your mask. So that's how the mask is looking now. I can make it a bit smaller. That's the effects. You can quickly invert a mask with the invert button. And also you can have multiple masks. So let's say instead of the placement mask, I create, for example, a circle. I can directly duplicate this circle with Ctrl D and get another circle which is added to the first one. So this is the blending operation between the masks. So it's not exactly the same as the usual blending operations, but for example, I can remove the second circle from the first one and create a moon-like shape. So that was not the purpose, but here we have all the basic components of one layer in Smode. The generator, the modifier, modulated by masks, multiple renderers, modifiers in the renderers, and of course, we can also put masks in the local modifiers. So for example, we could use noise masks. So in order to better see what a given modifier does, you can use the green arrow again. Let me check. Without the noise, it's like this. So input is the top part and the modified colors is the bottom part. This is how the noise mask looks like. So I will make it a bit smaller so we better can see. And now we have the colorize effect, which is modulated by the noise mask. So these are all the basic components, and I think I can save this compo, which is the reminder of layer structure. Next, we are going to see that, so for the moment, I only have one renderer, one modifier here, but modifiers can actually be combined. So let's start another layer to illustrate this. So this is one I very often use when I develop inside Smode because it contains all the type of visual information we need in order to test modifiers. And we are going to create two effects on this. So again, a blur. We can keep a simple Gaussian blur. And let's keep this aside for the moment. And we are going to create a distortion modifier. So you can see that the modifiers are organized per category. So color basically only affects the color of the pixels. It does not change the geometry of the image. Distort affects the geometry of the image, but it does not change the colors. And then blur is everything related to blurring the image in some way. So it can be also anti-aliasing and depth of field blur. And stylize is like combine modifications of colors and pixels of geometry. Utility are special modifiers, and then we have all the ISF modifiers, which are organized following the same categories. And also, as a reminder, you can take any layer where you want, press F1, select it, and you will have the associated documentation in the help column, where you can see the animated GIFs and so on that explain everything. So back to our LUT visualizer layer, I'm going to create the Droste effect. So Droste creates a kind of infinite repetition, self-recursive repetition, something like this. So it works better on some images than on others, but we will let's try to center on the teeth of Albin, which you saw the other day, by the way. And now I'm going to put the Gaussian blur again. And what we can see is that we have a sharp edge for the Droste effect. So in order to explain this, let's have a look at what happens. So first, the Gaussian blur takes the input image and applies the blur on it. And then, second step, the Droste effect takes the blurred image, so the result of the Gaussian blur, becomes the input of the Droste, and then the Droste effect is applied. So now what happens if we invert the two things? So also I remind you that the elementary inside Smode should always be read from the top to the bottom. You can think of it as the program that generates every single frame from Smode. So at every frame, like Smode reads this program line by line nearly and does the necessary stuff. So here, first it's applying Droste from top to bottom, and then it's applying Gaussian blur. So first we take the source image and apply the Droste on it, and then we take the Drosted image and apply the blur on it. And as you can see, the result is not the same because now the edges of the Droste are blurred because the blur is applied after. If I re-invert, I have the sharp edges. So this is very important to understand, and it will also apply to other type of layers, especially in 3D and also in shapes. So the order is really an important thing, and you should always think at what's happening in which order. And in the case of 2D, the green arrows can help you a lot in order to better understand chain of effects. If we go back, for example, to this, I'm going back maybe one step, just creating a single full placement. Wow, what happens? Let's take this one and fit it to the full image. So I showed you that we can mask color modifiers with any mask. That's what's happening here in this case. We have the goldenizer color profile, which is masked by the noise mask, this one. But masks work on all type of effects. So we could create, for example, a distortion effect. Let's take the 2D transform, for example. So 2D transform is super simple by default. It simply applies a transformation on the image. So for example, I can scale it and rotate it. And just maybe to make things more clear, I'm going to disable the other modifier for the moment. So that's what we have without the 2D transform. That's what we have with the 2D transform. So first of all, every modifier, you can change the intensity from 0 to 100%. So we can do this on the 2D transform. And what we see is that it's more or less transforming. It's interpolating between the start and the end position. And you can also do the same with masks. And basically, the masks, they correspond to the percentage you have here, but for on a per pixel basis. So for every pixel, Smode will compute 1% that tells how much the effect should be applied. So let's take, for example, a circle mask. Now what we see is, so the mask is like this, only the white part is selected. So in the selected part of the mask, the modifier is fully applied. And in the unselected part of the mask, the modifier is not applied at all. And now if I create some feeder, so instead of having this sharp circle, I'm going to make it smooth using the feeder option. Tadam! Something really strange happens, and it resembles to a black hole, like light going around a black hole. But what's happening now is it's interpolating between the unmodified position and the totally modified position. So if I augment the feeder, we can see the smooth transition between both. And this is actually a very, very powerful technique in order to create advanced modifiers inside Smode and inside chain of modifiers. So this combines very well with the different type of masks. So for example, we could use a 2D noise mask, and then we have this kind of shapes very quickly. We could use an image mask, so maybe that will be a bit complex on this case, but we could use a Bezier mask, linear. So now, according to a line, it's more or less applying the transformation. And as you can feel it, the combinations are really endless. So you can really spend a lot of time playing with this. So that was it about the reminders and the specific way we have chains of effects and in which the order is important, and also the specific way the masks can interact with the modifiers, especially when it comes to geometry spatial distortion modifiers. So now we have done some nice 2D. I will save this compo as other 2D modifier examples. So here, okay. And let's start another one where we are going to create a 3D layer. So there are different type of 3D layers. We can take, for example, a surface, a torus. That will be one example. And another example will be a grid points. So the grid points, let's remove the torus for the moment, is an array of points in space. So it has no surface, it has no lines, it only contains points. But it's very convenient. It will be very convenient in order to illustrate what I have to show. So if we look at what we have inside these two 3D layers, in the torus, we have a generator, which is generating a torus in this specific case, which has a given precision. And then we have a placement, which is where is the torus in 3D space. So we have a small warning because since we are using PBR rendering, I should be using linear, a linear gamma to make it happy. So, and then we have the renderer, which is rendering the geometry. And a 3D layer is exactly like a 2D layer in its structure. So you have a generator, a chain of modifiers that can be modulated by masks, renderers that can have local modifiers. And all of this is still relevant for 3D layers. The only difference, and it's a big difference, is that inside the 2D layers, it's images that flow through the chain of modifiers and through the pipeline in general. Whereas for 3D layers, it is geometries. So the generator creates a geometry, the modifier take a geometry as an input and create a geometry as an output. And the renderers take a geometry as an input and make some display on screen. So this being said, we can, and grid point is basically the same. We have the generator, which is the generating the points, and we have a placement, and we have a renderer that displays the points with sprites, and these two lines are relevant to the renderer. I will show them afterward. So now we can create modifiers. So basically, it's mostly the same categories as in 2D, except now we have the specific attributes category. So attribute modifiers operate on the attributes of the geometry vertices. So for example, the first one, and probably the simplest one, is the colorize modifier. And here you need to select a color. So let's put this one red. And what's happening is that the geometry is being colorized in red. So more specifically, what happens is that for every vertex of the geometry, so every single point inside the geometry, we are telling that this point color becomes red. And then, as in the 2D case, we can create masks, except this time it's no longer 2D masks, it's 3D masks. And more specifically, it is any property of the geometry vertices can be the basis of a mask. So let's start with maybe the horizontal texture coordinate. So now what you can see is that it's fading from gray, which was the unmodified color. So maybe I should first show that again we have this intensity controller. So unmodified state is gray. Let us put some light in the scene. So the unmodified state is like this, mostly white, and the modified state is totally red. And if we activate the mask, we blend from the unmodified state to the totally modified state. So what happens exactly is that for every vertex of the geometry, Smode evaluates the mask, and now the mask is telling the higher we are on the ring radius, the higher the more the effect should be applied, and then the effect is modulated by this. So this is with the U coordinates. This is what we get with the V coordinate. So now it's along the other dimension of the torus. And then we can create some other type of masks. So for example, the random one is taking a random value for every vertex of the geometry. So this depends on the number of vertices that we have put in the geometry, and that can be increased with the precision parameter. So now I'm adding more vertices. And yeah, so that's the random. We can do, for example, a sphere. And now it's masking, so the feeder depends on the exponents. And it's selecting the vertices that are inside the sphere. And the more they are inside the sphere, the more the modifier will be applied. So basically, it's the same as in 2D, except we really are working in the 3D space and with all the possible attributes of the geometry. Another very useful one is the 3D noise. So we can change the scale of this one, like this, for example, and play it to make it animated a bit faster, so we see something. And maybe with some more contrast. Yeah, this is a typical example. And again, the masks, they will work on nearly all the modifiers. It's not 100%, but really not far. On some of them, it makes no sense. But on all of them where it makes sense, they will work. So, for example, if you take the displace modifier, so displace is something that pushes the vertices along their normal direction. So you can change the distance of the displacement. So let's make it a bit smaller. And as for any modifier, you can interpolate from the unmodified state to the fully modified state. And now we can take any of our masks and put them into the displace effect. So let's take the noise, for example. I do control duplicate, control drag and drop to duplicate. And that's what we get with the noise applied. So now the noise is a bit strong, so maybe we can make it less strong, like this. And if we need more precision, we simply can increase the precision parameters. So this is simply a displace modulated with a noise mask. And this can also work, for example, on the 3D transform. So we did a 2D transform in the 2D case. We can do exactly the same in the 3D case with the 3D transform.
Francis,
Yes.
Can I interrupt you? We have a question of Takeya Mitchell. Say, I haven't gotten the idea of how layers works yet in Smode. Specifically, if I wanted to add a shader layer as a background of other geometry layer, it always just sits on the top of the main compo.
Okay, so maybe I can show this quickly. Let's create again. Let's create a 2D, another one. So game of life, for example. Well, it's not very readable. What can I do? Okay. So now we have this 2D layer, and it's indeed hiding the 3D object because the order in Smode is from top to bottom, always, always, always. So if you want to have this as a background, it needs to be first in the compo. And now it's rendering first the 2D layer, the noise shader, and second, it's rendering the 3D piece of content. If we go in the 3D view of the viewport, it's only keeping the 3D elements of the compo. So all the 2D elements are not displayed at all into this view, but thanks to this, we can navigate as in usual 3D software and go into the different views and so on. By the way, there is also the mixed view that enables to have one of each, one 3D and one 2D. And here we are back to the 2D view. So if noise now is here, it's indeed in front. And what happens exactly with the torus layer depends on the blending mode. So now if we put this in additive, for example, we will have the addition of the two layers. I hope this solves, this answers the questions.
Thank you, Francis.
Okay. So, oops, I'm back to my torus. And I was configuring 3D transform. So in my 3D transform, for example, I can rotate the torus and shift it on the side. So this is the unmodified state. This is the fully modified state. So by the way, as a reminder of last lesson, you can very easily create loops once you have a parameter like this. So that's one possible use of the 3D transform. but I'm just undoing. Most of the time, we use 3D transform in combination with a mask. And for example, let's make a sphere mask. And now what happens is that what's fully inside the sphere is fully modified, so it goes to the new position, and what's outside the sphere is not modified at all. So here I show it with a very sharp edge, which creates like some really strange artifacts, because this is computed one time per vertex. So if you don't have enough vertex, you have these ugly things. But with some feeder, you can most of the time fix it. And now we have this happening. So again, we can use noise mask, for example, and we will have this type of effects happening really quickly. One type of mask which is also interesting is the function mask and the layer mask. So let's start another layer where we are going to create a plane. So 10 meters by 10 meters plane, and I want 100 per 100 vertices on this plane. Now I'm going to displace the plane. So up, displace, and inside the displace, I'm going to create first a layer mask. So what is a layer mask? It's a mask that will take an image or a compo, and that will use this information in order to modulate the modifier. So currently it's uniform, but if, for example, I select a checkerboard, here is what's happening. So we can have a look at the checkerboard with the 2D view like this. This is the layer, and this is the result of the displays with the corresponding mask. And if I want this checkerboard to be a pre-comp, I can just turn it into a compo. And then I can start playing with this compo in any kind of way. So for example, I could use a blur in order to change the way the displays fades. So that's my current image. Or I could add a second layer on top of this. For example, text. And now you can see the smudge shape appearing in addition to the checkerboard. So we can make this look a bit better by increasing the precision. And that's how the pre-comp looks like. And then this is a very interesting combo, because the opacity of the layers that directly corresponds to levels of displacement. So all the compositing techniques apply in order to make more generative geometry stuff. So this is quite a useful trick. So this is the layer mask, and there is another interesting mask, which is the function mask. So we have some presets here. So basically, the function mask will first, it relies on an internal mask, which can be any of the masks we saw before, and it modifies it with a given function. So for example, we can do linear fx with a parametric function. So now what we have is a linear mask. It's along the wrong axis. So let me change the axis of the mask. Yeah. The little arrow you see here is the mask. So maybe we need to go from 5 meters to 5 meters. So the linear mask is basically applying the displays more and more along this line that we configure here. That's if we invert it. And if we look inside, if we look, sorry, Basil, you told me something, but I didn't hear you. Ah oui, okay, sorry. Yeah, Basil just was reminding me that we could see the two extremities of the mask like this, which can be convenient in order to configure the boundaries. And inside the function, we see the usual function editor you already know, probably. So, for example, we can use a sinus shape and let this shape be repeated multiple times, and this will be spread across the linear mask. So it's really in combination with a base mask, you put this function. So by the way, it could be, I don't know if you have like an audio. No, we don't have audio, but it could be a noise function also. And then we can play this noise function. Uh, frequency is a bit high, and we will get this type of results. So these are like the things to know mostly about masks. There are many other type of masks, but to move on, we are going to move on another type of geometries, which are point geometries. So particles are a particular case of point geometries. So the point geometries, you have them here. Grid points and random points are still points. They are not animated and not impacted by physics. And particles are simulated particles that are impacted by physics. So I'm going to start with the grid point first. So we don't have the physics aspect of particles, but all the rest I'm going to describe works also for physical particles. So here we can, just as a recap, do, for example, the colorize only on a sphere like so. Now you can really see the 3D mask idea. And you can see also that this grid point is displayed with some sprites. So let us disable the alpha layer of the compo. So we go back on the black background. Just to make things look a bit nicer, I can change the blending mode to use, for example, the screen mode, and I can reduce a little bit the opacity, I think. Not too much, of course. And also, I'm going to remove the depth test. So, oh, it's already removed. So, no, that's fine. So now these sprites, I would like to have some control on them. So because I have some global options in the renderer, like the size that they do. But let's say we want to change to have each vertex with a different sprite size. This is possible with an attribute modifier. So we won't take the colorize this time, but the point scaler. So every vertex inside Smode has a lot of associated information, such as the color, but also a scale value and a rotation value. So let's start with the scale. So the point scale is going to change not the scale of the geometry, but the scale information that is attached to the vertices of the geometry. So let's make them very small. So now it's doing like times 0.2. So this is the unmodified state. This is the modified state. As usual, we can interpolate between the two states with the overall intensity. And as usual, we can create masks. So for example, we could use the random mask. that provides a random value which is different for every vertex. And now we have this effect where every point has a random size. Of course, we could also use the sphere mask, for example. And if we keep only the sphere and inverse it, we will have the large particles only inside the sphere. And the normal way is the smaller particles, because my modifier is making the particles smaller only inside the sphere. So this is for the point scale, but you also have the rotation in the same order of idea. So maybe before showing the rotation, I'm going to change the sprite which is being used with, for example, this star, let's say. This one maybe. So I'm making the overall size a bit bigger. This is the size inside the renderer. So it's more a property of the renderer. And then I go back to the properties of the vertices. So this is the effect of my point scale. I'm keeping the random, which was nice. I think in the random you can use the power parameter to have some control on what exactly is happening, to make fewer big, very big ones. And then I'm going to create a point rotate. And this one is basically changing the rotation. So it's this one here, the rotation attribute of the particles. So let's put 0 on the X and Y axis and one full turn. This means one full turn on the Z axis. And now we have the unmodified state and the modified state. And again, we can, for example, duplicate the random masks to have a random rotation on every single vertex. Maybe it's going to look better like this. Yeah.
Francis?
Yes.
Yes, it's not a question, but Charlie had the idea to illustrate the point rotate and color with instantiate effect.
Yes.
I think.
Good
So
idea. So let's
maybe.
do it. So in order to do this, I'm first going to reduce the precision, because otherwise it will be hard to see what's happening. So let's go back to 3 by 3. Now you can see we have our 3 by 3 particle system. And I'm going to create an instantiate. So this is an operator. So concerning the categories of modifiers, we have the attributes, which are those we saw so far, that will change the color, the texture coordinates, the rotation and scale attributes. You have the distort modifiers that will change the 3D positions of the vertices. And the operator modifiers are like more complex modifiers that will take one geometry, do some non-trivial operation, and generate another geometry. And amongst them, we have the instantiates. And I can take a preset like to instantiate coins, let's say. And okay, so now something a bit strange is happening, because we are displaying with the sprite renderer the result of the instantiate. What I can do is add another renderer, because like for 2D layers, we can have multiple renderers. So I'm going to add a second one and just temporarily remove the first one. And now I'm displacing not the points of the geometry, but the surface of the geometry. And what we can see is we have our counts displayed, instantiated along according to the scale and rotate modifiers. The instantiate is actually specific to the surface, so I can move it as a local modifier, but no, that doesn't work. So we will have to create an issue, Basil, because that should work, I think. So I'm going to create a group just to put these coins instantiate inside. And now I can cumulate one renderer that is our sprite renderer, the camera facing sprites. And here I have a group in which I have the instantiate modifier that takes for every vertex and instantiates a coin which, by the way, is simply a cylinder with some preset values, and then renders this surface. And all of this, of course, still reacts to the masks. So we can take any of these parameters. Let's create, for example, a 3D noise on the rotation, and now we have every instance being rotated. Also, what's important to mention is that, again, the order is very important, because if you don't do things in the same order, you won't have the same results. So, for example, here, I'm instantiating after putting the attributes, but if so let's go back one step. I remove the point renderer, and now the instantiate, I will do it first, as a very first step. So now I'm putting for every vertex of the grip points, I'm creating one cylinder, one coin, and then I'm colorizing the result of this. So, but since the masks were not configured for this, the result is totally different. So if I want the correct result, I really need to modify all the attributes I need to modify, the color, the scale, the rotation, and then take the modified geometry with the modified, that was a wrong click, with the modified attributes, and then I can do my instantiate, and it will properly take all the attribute modifications that I did.
Francis, we have a small question of Florian D. Will there be other noise type implemented in the future, such as noises we can find in C4D, for example? So much convenient to create many different looks for displace effects. I
didn't show yet, but there are different types of noise here, which already provide some liberty in order to change the look. So maybe we can have a quick look at them by going back to the displays, not with this, but with 3D noise, for example, or 2D noise is also fine. So now we have a Perlin noise by Deco, but there is this parameter that enables to change the type of noise. And this is, for example, how fractured cell noise looks like. And then depending on the type of noise, you may have some additional parameters which are specific to the algorithm being used. So I'm not sure we have all noise that exists in C4D, but at least with this, and especially with the compositing techniques, you can generate a lot of things. Also, there is this octave parameter that will copy. So let's have a look at this layer in 2D. The octave will create multiple layers of noise with different scales. So now, for example, I'm additioning 5 layers of noise. Also, there is this absolute option that provides some other modification in the style of noise. So playing with all this, it's you have many options to create your own type of noise.
Maybe I can show us also a little tips and tricks about the displacement. Sure. If you want to create a kind of terrain, thanks to the displacement, you have inside your files and your standard pack, you go inside the preset directory right here, and just allow the shader pack presets, because these shader packs contain a preset of shader layer generator. that allow you to get a very interesting one. So for the to mask the just to mask the displays, I will create another one, another mask, layer mask. But this mask won't be a uniform, but a shader. And this shader must have inside the preset the colored shader. So
It's inside the shader pack, no?
it's inside the shader pack, yes.
Yes,
Here,
you had, yeah.
noise colored. And so it does automatically this displacement map. So this layer looks like that. So it can be very, very useful for many different purposes. It can be animated. So you have your player standalone. You are also able to translate through infinite these noises. So you can create a landscape like this. For example, I just put the uniscale to 2. No, 0.5. Okay. Maybe place my camera something like that, and just play with the translate to create infinite landscape. So that can be useful too, and noises can be found on the web thanks some shader code, and you can also customize your own thanks the basic shader and displacement in 2D in Smode. So that was it for these little tips and tricks.
Thank you, Erwan. It's a really nice one.
We
Yeah.
also had a quick question, not about modifiers, from Bert, who was looking for the color space of composition when you use PBR. I think it can be useful if you just show
Yeah,
inside the
so
composition the option to do that.
to make it simple, as soon as you plan to do PBR, I advise to use linear gamma value, and HDR 16 bits is enough by default, but you should put it like this, and then you can do PBR rendering, and it will be the good setting. Was that the question?
Thank you, Francis.
Yeah, thank you. So, yes, the order matters. Here we have this nice displays trick. So by the way, this is again a custom shader, and we will do a dedicated session soon with a special invited guest. So I will let you know this more. And maybe it's time to create our first particle system. So let's disable this one for the moment. Maybe we can save the compo with 3D layer examples and create a particle system. So Alban already showed you some particles, but let's start from the start. Basically, this is the emitter. So for the moment, it's emitting from a single point. We can, for example, emit particles from a plane. So here you can see the emission plane. Then you have the direction, the emission direction. So we can use, for example, the normal of the plane. So it will go perpendicular to the plane. And there is a spread parameter that gives a given amount of randomness into this. And then in the particles itself, you have like the initial speed. Let's make it a bit faster. And also the number of particles that are generated per second. And also the lifetime of the particles. So this is SMTP format, so 10 seconds in this case. Let's say 2 seconds instead. And now we have this point attributes modifier. So maybe I will show it just after, because the first thing to know is that you can absolutely reuse all the modifiers that we have seen so far. So for example, let's put all this thing we did into the group. Here I'm going to add I'm going to duplicate the group into the particles. And now I just recovered, so I need to remove this one. The things we did earlier. So instantiating a coin with random size, some red colors, and some rotation. So maybe to make it more obvious, I'm going to rotate also on the other axis. This. Oh, I need to put the coin after the others, of course. And what we need to know is that now that we are on particles, we have a new type of masks available, which is the edge mask. So, for example, instead of colorizing according to a sphere, or let's do this on the scale maybe, instead of scaling according to a random criteria, I'm going what sorry, the age. Sorry, I'm a bit lost. I'm going to use the age. So what's happening now is that when the particles are burning, the age is 0, so the effect is not modified at all. And during the lifetime of the particles, the effect will be more and more modified. And this is why we have smaller instances on the bottom part and bigger instances on the upper part. I can do the same edge on the colorize modifier, and now the particles are becoming red during the moment they are generated and the end of their lifetime. And basically, since most of the time we do particles, we want to animate the size, the color, the rotation depending on the age. There is an effect which is specialized for doing this, and which is the point attributes. So this effect basically has a selector, so the age by default, and then inside the function editor you can directly edit the different properties which are of interest for particles. So for example, now I'm going to increase the size of the particles during their lifetime. I can, for example, go and see the opacity curve. So if I need some fade in, fade out, I can directly create it here very easily. But it's also possible to create like more complex curves. So let's go back maybe to a very simple point renderer. Yes. So now you can see the different layers of transparency. Let's increase the speed slightly. We can also change the color, use the auto key for this. So now they will be starting red, then they will become like blue, for example, and at the end they become oh, that was not the one, etc. You understand me? The point attribute is simply a shortcut which does the same as the colorize, the point scale, the point rotate, and which is more convenient when you want to have keyframes all together and a single mask. But not that you can change the mask. So now it's the edge, but we still can use the other masks. So for example, if I change it by a sphere, now the function that I just created is applied along the sphere mask instead of the edge. And in the same spirit, I can show you a very relevant option of the sprite renderer, which is the fact that we can use multiple sprites. So in order to illustrate this, I'm going to import some other sprites. So for example, crosses and the shimmer and maybe another one. And now what's happening by default, so let's reduce the number of particles to better see what we are doing and increase the size. So now I have 4 images. First I have the cross, then I have the shimmer, then I have the star, and I finish with the dot white. And here you can see the selector, which is configured to the edge. So this means it's following the birth and to death of the particles. But as usual, you can change here. So for example, you could use random. And now you see that it's using a random sprite different for every particle. And also by default, it's always interpolating between 2 successive sprites. But this behavior can be removed with this option, the interpolation. And if we tell him take the nearest, then it will be a random single sprite among our selection. And in same spirit, you can use like sprite sheets like this one, the roses. So this is a 4x4 sprite sheet. Let's remove the other. So here is how the image looks like. So you can see it's a 4x4 array. So this needs to be told to the effect, and this is thanks to the parameters here. And now it just understood the sprite sheet as 16 different images, and it is taking a random image for each particle. So I can go back to the edge and again use the interpolation. And now, yeah, I think the previous was better. And thanks to this, you can create falling petals for TV shows, for example, very quickly. And it's usually always a good idea. I wanted to show you also another trick I love on particles. So let's go back one step before with the default sprite points renderer, simply the dots. We are going to use the additive mode, reduce the intensity, increase the size of the particles, maybe also slightly increase the number of particles. We can change a bit the system by using like random emission. So now the particles are still emitted from a plane, but with random directions. And here you can see some bad artifacts of the particles. So this is due to the fact that we need to choose between sorting the depth, but this can be a bit costly, but in general it solves the problem. So now it is sorting all the particles in order to display them in the right order for the blending to be correct. So if your machine is powerful enough, that's the simplest solution in the general case. But you can also disable the depth buffer, and then it will not try to occlude particles each with each other, because the artifacts we see is when there is a depth error, which is one particle hiding the particles which are behind it. So by disabling the depth buffer, we have a very quick solution. We can still reduce a bit the opacity and increase a bit the size. Okay, so now we have this kind of smoke, and what we want is to get some color into this, and a very easy way and very expressive way to put some color into this is by using the colorize layer attributes modifier. So this one, colorize texture layer. So for the moment, it's not happy because it complains that particles don't have texture coordinates. So indeed, texture coordinates only exist on plane surfaces and not on particles. But we are going to change this. But let's first pick an image. And for my demo, I will need an HDR image with nice bright spots. So maybe this one. And I'm going to put that one into the colorize instead of the uniform. So I'm using the Alt shortcut to replace the media. So here is how this map looks like. And what you have to know is that this map is HDR, meaning that the bright points, like this one, for example, they go far beyond classical white. This, like the central point, maybe is 1000 more bright than the normal white. And this is what makes all the power of HDR. So basically all the light sources are above the normal white. And now, so the way the colorize work is that by default it's taking the U and the V coordinates in order to know where to look at into the image in order to decide the color for the particle. But we can change this with any mask. So for example, we could say, take a random X coordinate inside the image, and your Y coordinate will be the age of the particle. And now we get this. So what is happening? For every particle, it takes a random horizontal position, and the age has a vertical position. So back to this image, every particle will become a vertical line, and during the lifetime of the particle, it will go from the top to the bottom of this vertical line. And the specific vertical line will be different for every particle. So with the image, we are expressing color gradients, a collection of color gradients, one for every particle. And we can see the brighting points that come from the fact that we have the HDR image. So let's a bit abuse of the GPU. Now we have this very nice looking shining effect that simply reflect the light halos that exist in the image. So I can change this one and it will immediately change the whole look. But as you can see, it's working less good on PNG and JPEG images because by default these are 8-bit images. So it changes the overall tint. We can adapt with the blending to get something satisfying. But this really works best when you have HDR, then you will have the very bright dots and get this really good looking effects.
Francis, we do have some question about what is the best for performances between the resolution of sprites and the number of particles.
So in general, you can go very high in the number of particles, but the bottleneck is to display them, and it will be the number of pixels that are drawn, the pixel fill rate. So to evaluate it, it's the size of one sprite, the average size of sprites times the number of sprites. So this means that you can like simulate millions of particles if you display them. For example, there is another renderer, which is the simple points. And instead of using a sprite, it's simply displaying one pixel at a time, or a few pixels, depending on the size you put here. But with this, you have a very low fill rate. It's only 1 pixel per particle. And when you use this, you can go very high in the number of particles. It can be several millions, actually. But if then you start using large sprites, the performances will drop very, very quickly. So just now for the info, I think we can see the number of particles somewhere. Yes, now we have 7,000 particles, but we can like add 2 zeros here. we have nearly 1 million particles, and it's not an issue for the machine. We still are at 60 frames per second, so let's add another 0. So now I need to unlock the maximum count, because this is a protection to avoid exploding the GPU. But since we know it's okay, we can tell him to go up to 10 million. So now we have this. Just we can make this look a bit nicer with the additive. So we are simulating 7 million particles. It goes nearly well, because the renderer is very simple. But I won't even put the sprites now, because if I do this, it will be very bad for my demo. So first, I'm going to reduce a bit the number of particles. So let's go back to something a bit more reasonable. No, 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 not this. Ooh, ooh, ooh. View. And now we can again use the other sprite renderer. So this was a bit violent for the connection, but it's going back. Yes, I can put my sprites again. Are there some other questions?
No, it's okay for now. Thank you.
I think, Erwan, you had a trick that you wanted to show us about the motion lines.
Yes, it's about the motion lines modifier. So maybe I can use your particle system,
Yes.
just create another renderer, another group of modifier. Let's try this with the colorized texture layer already applied. So the effects I really use often in Smode is motion lines, because motion lines actually trace your particles through the space. So for every movement applied before the motion lines, it creates some lines and some vertices. So you can use those vertices to display some stuff. So maybe I can decrease the number of particles to 200. So, okay, the perf are better. Something I really like to do with motion lines is to select this modifier, put the steps at 100 at least, so it creates longer traces. I always add a little position noise to this. So here I have the choice. I really put this one before the motion lines. Let's decrease a little the intensity of the position noise. And the tricks is inside the renderer, the default line renderer. So this is your map of your motion lines, and you have to understand this little square as a trace of the motion lines. Like it begins with this point and end with at this point. So you can pre-comp this this uniform. So maybe I can simply add, I don't know, this not in uniform, but in a composition. So let's visualize my composition. Change the resolution to have a more understandable generator for this effect. So 1000 per 200. Yeah, something like that. And the thing is that I always mask the uniform thanks Bezier mask. So I create this little shape, something like that. Take both points at the up and the bottom of this shape and set to cubic to have a smooth shape like this. So this is what I get. We can't see very well because the only thing I need to know is to increase a little the thickness of my default lines and maybe don't test it. Why did I have those points? Is it inside?
Maybe we still have the particles.
We don't have the particles right here. Let's see. Is it the speed? Maybe the speed at 1 will be better. And the plane, decrease the plane at 1, 2.
But I think your shape is not going till the end of the compo, maybe?
It's not a kind of problem habitually, but for this example, yeah, it's make some straight and strange. Maybe just remove the colorized layer. No, that's not the problem. Or simply put this one in parallel, so I have the same direction.
Yeah, it's not a big deal, Erwan.
No, but this is the shape you get inside thanks this modifier and using this renderer. So I always create two renderers inside the composition. So Control Shift A. So inside my composition, I want to have one turn into black. So let's invert the color of this one. And the second one in white, but let's decrease it to have some border to my shape. So let's put this like that. And this creates this kind of shape. Let's test the depth again. And yeah, this is how I create a lot of some visual and stuff like that. Let's put the colorize again. Colorize layer, do something like that. Just add a colorize function. So this is a question of order because colorize function placed after motion lines colorize randomly the lines traced by the motion lines. But if you put it before the motion lines, it colorizes the point, and the color of the point will be the color of your lines. So this is what you get. And keep in mind that if you create a distortion 3D transform also before the motion lines, because if you put it after, it only play with the generation made by motion lines. If you put it before and play with the direction, you can create stuff like that. So for example, simply create a linear loop in y-axis and you create something a really strange shape and traces shape. And yeah, that was it. Sorry, Francis, I have changed a lot of things inside your particle system.
I'm sorry for those that will reopen this purpose.
Yeah.
Yeah, thank you for this little trick. It's indeed a bit strange. We get some artifacts. We have to look at this more closer. But it's nearly the end of the live now, so I propose to very, very quickly show that shape layers are exactly the same. And if you understood the rest of today's session, you normally know how to use a shape. So I create a shape layer, a star, for example. This shape layer has a generator, a placement, and a renderer. So the renderer has two options, one to fill the fill color and one for the stroke. You can select the width of the stroke, is it inside or outside the shape, this type of options. And then, as usual, you can put modifiers. So, for example, there is the stroke modifier that will stroke your shape. So we can let this appear with a back and forth loop. And we can, for example, use another modifier, which is the instantiate. For example, I want to instantiate some arrows onto the shape. That's a big arrow. Let's make it a bit smaller. And again, it depends on the order between the modifiers. So instead of attaching this to the caps, I'm going to create arrows. So let's remove the stroke quickly. Now I'm instantiating arrows at different locations of the shape. Let's put the thickness a bit lower. And maybe more stars. More stars, twinkly stars, and maybe smaller stars. So I'm putting some triangles along the shape. So there are a lot of options, and probably we need to do another dedicated live onto this. Maybe I'm just going to use the replace. Yeah, so now you can see really the effect of the instantiate. Now we have 50 triangles, and if we stroke after, we will have one result. If we instantiate after the stroke, we will have another result. So order is important. Another type of modifier are the attribute modifiers again. So for example, there is the edge centering modifier that enables to change to move along the shape. So in order to illustrate, I'm going to, yeah, so now I'm using like a triangle shape, which is repeated. And this modulates the centering of the edge. And I can also use masks as usual. And now, for example, for this circle, it is only applying the modifier inside the circle. So this mask can be images, for example, and this quickly leads to very creative solutions for making new type of visuals. So in a word, shape layers work exactly like geometry layers and texture layers. And I think that's my conclusion, unless we have some questions.
Yes, we do have two questions. So the very first one from Jacob L. Anderson, which is pretty complicated. How do you stick the particles to a 3D geometry and tracing the geometry with the same moving particles so it does not die out? I think we
Yeah.
do mention maybe the compo based, but
Yeah, maybe it's going a bit far, but because it's already quite late. And I mean, what we have is exporting particles from geometries, but there are not that many options. Particles can collide with simple geometries. They can be emitted from any geometry, but that's mostly the type of interactions you can have with geometries.
thank you. And we do have another question from Charlely. Do you have a button to go directly on a 3D object center view in 3D navigation?
Yeah, the F is expected to do this, but I'm not sure it really works well.
No.
That's the whole of the F shortcut, but I know we have still some bugs on this F shortcut. So normally you have the F, but we still need to improve these points.
Thank you, Francis.
Perfect. So what's coming next?
What's coming next? Coming next will be special live because we are glad to be with Jordi Masso, one guy one of the one CG artist from the Iceberg Studio in Barcelona, who will talk about his experience, gives, I think, some little tips and tricks, and also speak about DOM.
DOM in particular, he will explain us how to use Smode in order to generate DOM content. So I just created a quick blur to finish. with a nice image. But indeed, we are very happy to welcome Jordi tomorrow, and he will show us the amazing DOM content he creates with Smode, and also he will explain his C4D substance and Smode workflow. So it's going to be super interesting. So see you soon. I hope you enjoyed this live. As usual, you can ask questions either on the forum or on the small user group, or simply during the next lives. So enjoy your evening and see you tomorrow.
See you guys.